I learned .NET in 2001, and somewhere around October 2001 to be somewhat more precise. Um, so during that time, I had, uh, like most people, read a lot of my, or got a lot of my information from books from the likes of Rock's Press. Much of my corporate and business software development involved what you call classic ASP, VB script, and Visual Basic, among other technologies, as well as JavaScript. And so Rock's Press was a reputable and reliable conveyor of information about these things. Well, one of the books that they came out with was Beginning VB.NET First Edition. And Beginning VB.NET basically told you a lot about .NET, and you had a book that was published around the same time called Beginning C Sharp, and I was alternating between Beginning C Sharp and Beginning VB.NET because, like many software developers in the Microsoft world at the time, the majority of us used the Visual Basic. In the beginning, we were Visual Basic developers on the Microsoft platform. When they started developing .NET, they wanted to use this language called C Sharp. C Sharp was modeled off of Java, but I was already experienced in and had much of my background in Microsoft technology. So I said this would be a good transition for me. So my first review on .NET, July 7, 2002, right? I read this book called Applied Microsoft .NET Framework Programming by Jeffrey Richter. And what that book did is it showed how much of C Sharp and .NET at the time was defined in C++. So Jeffrey Richter pulled back the curtain on how .NET was implemented underneath so that you could gain greater insight. So I waited out the whole .NET Core thing, and I just stayed with .NET Framework, and then I jumped back in on .NET 6. So I said, okay, we got .NET 6, we got .NET 7. Let's work with that. Let's tiptoe into that. And then by .NET 8, I was really going into it, and now I'm all in with it with .NET 9. So I see some very interesting aspects with .NET on Linux, more than what has been discussed, I think, anywhere. And I'm going to bring that up in a future video. And if I am right about what I'm going to present, it's going to be pretty mind-blowing, right? And the tools are all there, but it's how you put it together. And the thing about .NET is that I took a parallel journey. So I did Microsoft .NET, right? I dabbled in Java a little bit way back when and along the way, but I pretty much stayed mainly with .NET. And then at the same time, I have a parallel course that I did. So I did both of these at the same time. Here I did Linux and C++ and C and Bash and all of that. So I became dual skilled, right? So I'm dual skilled in Microsoft world and Linux world, right? So previously this was all Windows, right? And this was all Linux, and they were completely separate. But when Microsoft started acquiring GitHub, and they started doing Windows services for Linux and all that, guess what? They started to come together. So now it's like I made the right bet on Linux, and I am glad I invested in .NET because here's the thing. .NET gives you a level of productivity that is important in writing software where you want that software to also be reliable, structured, and somewhat deterministic in how you use it, right? And so I see many optimistic directions for .NET. And so if you found this part of the discussion interesting, let me show you something else that I've been doing with this process. I have a program that I wrote in .NET on Linux. I wrote it by hand. And basically what it does is it provides an informal stress test of the system. It's what I call a very informal stress test of the system. I also have a C++ version as well. So what I want to do is I want to show you something that I found interesting about C# on Linux. So this is very straightforward. We're just going to do a couple of what I call cycles. So what a cycle is a cycle encompasses all the instructions that you want to run within that cycle. So so to say it a different way, here a cycle refers to a second. So each second that passes, how much work can we do each second that passes, right? So let's go ahead and do like 1,000 of these and just let it run. Well, actually, I won't. Let's just do 700. So let's do 700 of these because I believe that if I do 1,000, it's going to take like 15 minutes. So let's just do 700 so that we can shorten this a little bit. And then while this runs, I'm also going to show you something else. So let's run the C# version and let's run the C++ version at the same time. Now you notice that starting out that they basically iterate in a somewhat equivalent time frame, right? And so the cycle that they're on, right, are roughly the same. I did start the C# version slightly earlier than the C++ version by about half a second. So that's where you see that differential there. But what is more interesting is if you look at each cycle, right, and the number of iterations that we do per cycle, in the C# version, we are averaging about 250 million iterations per second. In the C++ version, we are averaging about 13 million. So there are more iterations accomplished in the C# version than in the C++ version. Now, you may be asking the question, what is going on in the C# version and the C++ version? So this is the project that I built in .NET on Linux. I did it all on the command line, so I didn't use VS Code. Let's open this up. I'm going to just go ahead and delete these directories here. Those include our binaries, or they did, but now no more. Let's see. So we'll just build this. So by default, it's going to build a debug version. So let's also build a release version as well. It's the release version that I'm actually running. So I'm running the release version, and then that's what's actually executing, right? As far as the source code, it is very simple program, right? I wrote this by hand, 23 years of experience with this. You know, this is just basically done from memory, right? In terms of knowing the APIs, knowing, what functions to call. A much more complicated program than this, then so I still have, even after all that time, I still have to look at reference manuals, right? But there are many things that I've done where it's like, okay, I don't need to do that. So anyway, basically, you have a general outer loop, And one of the things that I do is I synchronize this to the system clock, and I want this, if at all possible, to run on what I call the zeroth boundaries of time, right? So if it is 3:04 and 53 seconds, I want to wait out until we get to the top of the minute, right? So instead of 3:04, I want to run at 3:05, right? Or if it's 3:05 and 13 seconds, I want to wait until 3:05 and 20 seconds, right? So that's how this is set up to make sure everything is aligned appropriately, right? And so then the actual work that's being done is done here. It's very simple, and it has a couple of things that it's doing. It's doing some math operations. So it's doing a couple of math operations here. It's using modulus, right? It's doing increment, and we're also doing equality comparison. We are invoking a object, right? So there's heap access. So we got stack and heap access, right? Notice that I'm using a native unsigned integer. So that's going to prevent integer overflow if we decide to run this for a million iterations, right? And so, yeah, so it's pretty straightforward what this does, right? And then we have the C++ version, right? And I'm actually going to obliterate all of its stuff. So let's close that out. And just compiling it is pretty simple. I hadn't came up with a better word yet, so I just called it timer, right? And you can actually do all kinds of flags and everything, but I wanted to do something more default with the way I compile this. You could do, I believe, O3 fast or something like that. I have it in a script somewhere. Loop unrolling, and you can do machine architecture equal to x86-64 or something like that. But anyway, the C++ version, let's take a look at it. Now the C++ version, I wanted it to have, I wanted it to match the, I wanted it to match the C# version in terms of how everything is laid out to the screen. And so while I wrote the C# version by hand, right, I said, okay, this is where we can use AI. So I used ChatGPT o1, and I said, hey, take this C# file, and I program my ChatGPT instance. It has very specific standards, and I said, um, I want you to go and make an exact version of this in C++, because AI is pretty good at that sort of thing, right? It's not going to build a program from scratch, but if you have a quality program that you know works, then you can have it just replicate that program in a different language. So here I'm using unsigned int fast32t so that we have the fastest integer for the platform, and it will vary between 32 bits or 64 bits depending on what's going to be fastest for the implementation. I have some custom format functions. It's actually much more verbose than the C# version in terms of what it does for doing the exact same thing. It's far more verbose. So this is the code that has to be written in C++ unless you are using some third-party libraries. But this uses the standard template library, the STL. And I made some optimizations beyond what ChatGPT was able to do. I actually introduced this. I wrote this. I have a formatting function here because it wasn't formatting things properly. I did some optimization here with the buffer. I just wanted it to output a certain way, and so I had it correspond to the way I was doing the buffers here with the string builder instances. So, long story short, I have identical implementations, one for C Sharp and one for C++. And what I observed, accounting for the synchronization, the time synchronization, even when I take the time synchronization away, the number of iterations per second does not deviate significantly. And so, unless there's some other factor that I have not accounted for, and I am willing to say that there's another factor I haven't accounted for, the C Sharp version on Linux, pretty much out of the box, even with the release flag, pretty much out of the box, because actually the debug version runs somewhat similarly. It runs faster than the C++ version. You can calculate more per second with the C Sharp version over the C++ version. You can do some things in C++ to have it totally take the speed crown. But that's not the point, is it? The point is to be able to use high-level abstractions, because that's the whole direction of C++ 11, C++ 14, C++ 17, C++ 20, C++ 23. The whole direction of the new C++ is to write everything high level, use smart pointers, and in fact, in this case, I don't use pointers at all, and to basically do things in C++ the same way in terms of concept, in terms of ideology, the way you would do it in Java, C Sharp, Swift, TypeScript, and dare I say, Python. And so here's our result. They finished exactly the same time with just a slight variation in the milliseconds. So the C Sharp version was only 722 milliseconds faster. That's it. Not huge. So you don't have a huge difference in performance. The performance is equivalent. And the thing is that for me, this exercise completely destroyed the idea that C++ is going to be faster out of the box in all cases. I'm talking about the compiler. I'm not talking about the language. So this has been eye-opening for me. Um, but yeah, so this gives me confidence in .NET in the Linux environment, in the server environment, of .NET for scripting, you know, because some of us we can write C Sharp as fast, if not faster, as somebody writing Python. So for just doing ad hoc file utilities, ad hoc scripting tasks in Linux, C Sharp would be much more competent for introducing structure, class libraries, and having process around it, but not doing it in such a way where it also slows you down significantly, right? So there's a better balance there. We're talking about the whole conversation around Rust, right? You want memory safety. You got memory safety in C Sharp. So C Sharp, if it continues to evolve the right way, it could replace C++ on in the Linux environment.